So good day, grade 8 Math Science High School students and also to our viewers. Okay, so we have here our third lesson for the third quarter. So we have lesson 19 for module 19. We have the basic proportionality theorem. So let's go and jump right ahead with our problem. We have Fe and Sandra on their spare time tried to outline the mini fortress that they needed to build for their Art of War game with their friends. So the girls drafted this figure below. So we need to find the value of x and y to help the girls with their fortress. Okay, so for this problem, dear students, so how can we solve for the value of x and y? So this topic is about the basic proportionality theorem, but also we're going to do an introduction to similarity of triangles since these topics are very much related to each other. Okay, so to solve for the value of x on this one, we're going to be using similar triangles, and also to solve for the value of y, we're going to be using similar triangles as well. What do you notice about these triangles, guys? So this triangle here, that's triangle BDE. Okay, triangle BDE is similar to triangle BAC. Triangle BAC. They have similar measurements. Same as with triangle BAC. Okay, triangle BAC is of course similar to itself using the reflexive property of equality. Okay, so let's start first with BDE and BAC. To solve for the value of x, we really have to look at these two triangles here. The small triangle here and at the bigger picture. So this is the bigger picture, the bigger triangle that we have here. So the measurements of triangle BDE, we can create a ratio for that one, the side measurements of this triangle. Okay, we can create a ratio for that since we know that based from triangle similarity theorem, in order for the triangles to be similar, they just need to have similar sides but congruent angles. And in this figure, they do have congruent angles for this one. You can see both triangles having 90 degrees. So therefore for BDE, we can say that BD all over DE should be equal to BA all over AC, where AC is equal to x for this one. And for the other triangle, okay, so it's going to be congruent to itself, we can also say that BD all over DA is equal to BE all over EC. Okay, and where EC is going to be the y. Okay, so this is going to be the y variable. So we have our two variables that we need to find for this problem, all stated, okay, and all clarified and organized. Then we can now solve for the values of x and y. Since we know that BD is equal to 12, so let's plug that in. All over DE, which is equal to 9. That's gonna be equal to BA. Okay, so where is BA? BA is the sum of DA and BD. So that's gonna be 12 plus 8 all over AC, which is x. Okay, and what's 12 plus 8, guys? So that's just gonna give us 20 all over x using cross multiplication, okay, or extreme means property. So we can say that 12x is equal to 180 and dividing both sides by 12. So therefore we can say that the value of x is equal to 180 divided by 12, it's equal to 15. So therefore x is equal to 15 feet. Okay, so for this problem is equal to 15 feet. So how about for y? Since we know that BD is equal to 12 and DA is equal to 8 and BE is equal to 7.8, okay, we just need to find the value of EC, which is y. And again, using the extreme means property, ratio property, or the cross multiplication that we all know. So this is just gonna be 12y. Okay, 12y is equal to 7.8 times 8. And what's 7.8 times 8, guys? So that's just gonna give us 62.4. So 12y is equal to 62.4, and if we divide both sides by 12, we can get that the value of y, we can solve that the value of y is equal to 62.4 divided by 12, so that's just gonna be 5.2 feet. There you go. So therefore the value of y for this problem, y is simply equal to 5.2 feet. Okay, so x is equal to 15 feet. Okay, so that's 15, and y is equal to 5.2 feet, and that's shown in this should be shown in feet. Okay, shown in feet. Okay, so that's how solve this problem.